FCFS means first come, first served, starting the first job in the optimal sequence on a machine A and completing the last job in the optimal machine B. That is called the total lapse time. SPT means the shortest processing time, the time between starting the first job in the optimal sequence of the machine A and the final and completing the last job in the optimal machine B. Hello dear students, welcome to this session of Operation Research class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. Today I am going to discuss regarding very important concept, that is job sequence. In this job sequence, we are going to study regarding Johnson's rule, very important concept, that is regarding Johnson's rule to solve the job sequence problem. Now, before going to that, let us know regarding what is sequencing problem. Now here it is the selection of appropriate order. So selecting an appropriate order in which a number of jobs or operations can be assigned to a finite number of service facilitators. So here this is nothing but the process of selecting a job, process of selection of an appropriate proper order in which the number of jobs can be assigned to a finite number of service facilitators, that is nothing but for a machine or an equipment, so as to optimize the output in terms of the time, cost or profit. Two outputs are in the terms of either it may be in the form of a time to get the minimum time and cost or profit to get the maximum profit, and to minimize the cost and to minimize the time, we are using the concept of sequencing. For that sequencing, we are going to select an appropriate order. Order of the sequence is very important. That is what we are going to perform. So the selection of appropriate order in which the number of jobs or operations can be assigned to a finite number of machines, like machines or equipments, so as to optimize the maximum profit, minimum cost and the minimum time. Now, so we are getting the order in the form of a sequence like this: A to B or B to C or C to D or D to E. So this is called the sequencing. This is the sequence first. Now let us come to the common sequencing rule. How to get the common sequencing? So before that, let us know regarding some definition and the abbreviations. Now what is FCFS means? FCFS means first come, first served. That means job processed in the order they come to the shop. So the jobs can be served in such a way that first come, first served. So FCFS means first come, first served. Jobs can be processed such a way that they come to the shop first. Okay. Now second one, SPT. SPT is nothing but the shortest processing time. SPT means the shortest processing time. Here jobs with shortest processing time are scheduled first. So we are going to schedule the jobs first which process the shortest time. So that is called as a SPT, shortest processing time. Here the jobs with shortest processing times are scheduled first. Now next, EDD. EDD is nothing but earliest due date. Earliest due date. So if it is due date is early, then the jobs are scheduled first. The jobs are scheduled first depending upon the earliest due date. If the due date is very near earlier, then such types of jobs are scheduled first. That is called EDD, earliest due date. Now the second one is the critical ratio, CR, the critical ratio. So critical ratio is nothing but compute the ratio of the processing. This critical ratio will compute the ratio of the processing time of the job and the remaining time until the due date. So critical ratio will process, this will compute the ratio of processing time of the job to the remaining time until the due date. So that this schedule the job with the largest CR value to the next. Okay. Now let us come to the next concept, two work centers. So two work centers of the sequences. Johnson rules technique for minimizing completion time for a group of jobs to be processed on two machines or two work centers. That is called a two work center or two machines. So minimize the total ideal time. First minimize the total ideal time, then several conditions must be satisfied. So to apply the Johnson's rule, first we have to minimize the ideal time and several conditions must be satisfied. What are the conditions? The conditions are here, the job time must be known and constant. Very important concept is the job time must be known and it should be a constant, it should not be varied. Then job time must be independent of the sequence. It does not depend upon the sequence. The job time is constant. First of all, it must be a constant or noun. The job time must be independent of the sequence. It does not depend upon any other condition. So it is independent of the sequence. And the job must follow same two-step sequences. So it will follow the same two-step sequences. And the priorities cannot be used. Job priorities cannot be used here. Now, all the units must be completed at the first work center before moving to the second work center. First, we have to complete all the assigned work in the first center. Then, after completion, we have to go for the second center. So, sequencing problems, in sequencing problems, so one machines, many jobs, there are different methods. One machine, many jobs, two machines, many jobs, three machines, many. One machine can do so many jobs. Similarly, two machines can do so many jobs. 3, 4, n machines can do n different jobs. So, here let us know the Johnson rules. Step-by-step procedure to solve a sequencing problem using Johnson's rule. What is the step-by-step procedure? Now, list the job and their times at each work center. First, we have to list the jobs. What are the jobs assigned? And we have to list the job at their work center. That means their times must be listed. List the jobs and their time at work center. The second step is select the job with shortest activity. Minimum value is to be selected. Shortest activity time. That is, select the job with shortest activity time. If that activity time is for the first work center, then schedule the job for the first. So we have to choose the minimum value. If it is minimum for the first, then we have to assign it for the first. Then schedule the job for the first. If the activity time is for the second work center, then schedule the job for the last and break the tie if it is available. If at all any tie, we have to break the ties arbitrarily. Okay. Now just select the minimum value and assign for the scheduled job. Okay, if it is for first, we can assign for the first. If it is for second, we have to assign for the second work center. Eliminate the shortest job from further consideration. So we have to eliminate the shortest job from further consideration. We have to eliminate that. Now repeat the step 2 and 3. That means select again the shortest value and assign for the first. If it is, again, if the activity is for the second, then assume the, then assign the work for the second. Okay, so the process is repeated until all the jobs have been scheduled. So until all the jobs have been scheduled, the process is going to repeat. Now, I'll explain this step by step while performing the problem. Now, process of n jobs through two machines. This is an important concept. In the examination, you will get this type of problem, processing the number of jobs through two machines, M1 and M2. Now, let us consider the simplest sequencing problem is that n jobs, two machines, M1 and M2, sequencing problem in which we want to determine the sequencing in which n jobs should be processed through two machines so as to minimize the total elapsed time, and the problem can be described as only two machines A and B are involved. Each job is processed in order A to B. Okay, the exact or expected processing time will be, suppose if A1, A2, A3, AN is the processing time, then B1, B2, B3, etc. Bn are known and are provided in the following table. Okay. Now, suppose let us consider the exact or expected processing time. If A1, A2 and A3 or etc. An are the exact processing time, B1, B2, B3 are the values which are known, then the table, this will provide condition. So here the machines, there are two machines, machine A and machine B, and the number of jobs are 1, 2, 3, 4, etc. n. So A can do A1, A2, A, etc. An jobs, and B can do B1, B2, B, etc. Bn. So this is how they are going to give a problem. Okay. Now, so here the number of jobs and the machine. So in some examples, we can consider the machines as M1 and M2 also, right? Now let us come to the step-by-step procedure to solve a sequencing problem using Johnson's rule. Now, so step-by-step procedure to solve a n jobs. So to find the sequence or order of jobs so as to minimize the total elapsed time, the solution for the problem using Johnson's rule can be solved step by step. So this is called the step-by-step procedure to solve a Johnson sequencing problem. First set. Now let us come to the step 1. In the step 1, select the smallest processing value or processing time occurring in A1, A2 and A1, AN. So let us find out the smallest value in this A1, A2, A, etc. AN. So just find out the smallest processing time, the least value. Just find out the least value in A1, A2, etc. AN. And then if B1, B2, B3, etc. Bn, if there is a tie, okay, either of the smallest processing time can be selected in B1, B2, B3 also. Now, step 2, just find out the least value in A1, A2, An, etc. as well as in B1, B2, B3. If there is a tie, either of the smallest processing time can be selected. Now, step 2, if the least processing time is AR, select rth job. Suppose if the least processing time is AR, then we have to select rth job first. If BS is the least processing time in B, then we have to select the S job in B. So the job lost the given order A to B. So we will get the sequencing in the order A to B. So here, if the least processing time is AR, then select rth job. If the least processing time is S, then we are going to select BS, so that the last job as the given order A to B. Now go to the step 3. What is step 3? There are now n-1 jobs left to be ordered. So after selecting, there are n-1 jobs are left which is to be selected. So repeat the steps 1 and step 2. Just find out the least value in M1 and least value in M2. That's it. Okay. Assign for the particular sequence. Then remaining set of processing time obtained by deleting the processing time for the both machines corresponding to the job already assigned. Now, next step is continue the same manner till the entire jobs have been ordered. So this process is continued till all the jobs, still the entire jobs have been ordered or in order have been ordered. The resulting order will be minimize the total elapsed time T and is called the optimal sequence. So the process is continued until we will get all the jobs to be assigned in order, and the resulting order will be minimized to the total elapsed time T and is called the optimal sequence. Now, next step is after finding the optimal sequence as stated in the step 4, find the total elapsed time and ideal time on the machine A and B. We have to calculate the total time lapsed as well as the ideal time, the rest time for machine A and machine B. Right. Then the total lapsed time is nothing but the time between the starting the first job in the optimal sequence on a machine A and completing the last job in the optimal machine B. That is called the total lapse time. The total lapse time is nothing but the difference between the time between starting the first job in the optimal sequence of the mission A and the final and completing the last job in the optimal mission B. This time gap will give the lapse time. Now, ideal time on the mission. What is the meaning of this ideal time on the mission A? Time when the last job in the optimal sequence on the sequence is completed on the mission B minus the time when the last job in the optimal mission of the sequence is completed in the mission A. So, that is ideal time is nothing but the difference between the time when the last job is completed in mission B and the last job completed in the mission A. That is the time when the last job is in optimal sequence on the sequence is completed by the mission B minus time when the last job is in the optimal sequence is completed in the mission A. The difference between the time in mission B and mission A will gives the ideal time on the mission. That is the ideal time, total lapse time. This is very important. That is what we are going to determine. So, in the sequencing problem, so we are going to find the total time lapse as well as the ideal time. Okay. Ideal time on mission A is nothing but time when the last job in the optimal sequence is completed by the mission B minus the time when the last job in the optimal sequence is completed on the mission A. Okay. Similarly, ideal time for the mission B. So, is nothing but the sum. So, let me see. The ideal time for the mission B is nothing but time when the first job in the optimal sequence completed on the mission A plus the time when the last job in the optimal sequence is completed in the mission B. So, completed in the mission B. That's it. Now let us know regarding Johnson's procedures illustrated by the following example. Let us consider an example. So, in the examination, they may ask 5. Explain the step-by-step procedure to solve a sequencing problem using Johnson's method, or they will give a question like this for 7 or 8 marks. The problem will be like this. Solve the following sequencing problem using Johnson algorithm method. Find the total runtime or lapse time and total ideal time. So, what is to determine total runtime, lapse time as well as the total ideal time? So, what is the condition given here? There are 5 jobs A, B, C, D. These are the jobs and this can be performed by the machine M1 and M2. Time in hours. So, the machine will perform the following time in hours 4, 3, 5, 7, 8 and machine 2 time in hours is 2, 9, 1, 3 and 5. For this we have to find out the sequencing first, then total run time, lapse time and the total ideal time. Now, let us find out the sequencing order first. The very important is the sequencing order. Now, how to find the sequencing order? Just here. So, to find the sequencing order 1, 2, 3, 4 and 5. So, let us consider this is for mission 1, M1 and this is for M2. Okay. Now, so to find the sequencing, now just in the table, in the given problem, find out the minimum least value. What is the least time here? This is the least time. 1 is the least time. So, this will comes in the right for the mission 2. This is corresponding to C. So, you can assign C here. So, once by assigning, you can cancel this entire row. Okay. Now, let us come to the next least value. Next least time is here it is 2 again. 2, this is in M2 mission. So, here this is corresponding to A. So, cancel this, we can write A here. Okay. Now, let us come to the next least value, next least processing time. What is the next least processing time? We have tie here 3 and 3. So, you can choose this 3 and assign for B. So, this comes for the mission 1. So, you can choose the mission 1. So, M, that is nothing but B. Next, the next least value is nothing but 3. So, you can choose this 3 and this comes in the right side for the mission 2. This is nothing but for D. And what is left over is 5. The least value is 5 and next mission is E. So, this is the sequencing. The sequencing order is B to E, again E to D, then D to A and A to C. This is the sequencing order. That's it. Now, I will write this here. The sequencing order is B, E, D, A and C. That's all. This is the sequencing order. So we are applying the Johnson's rule for sequencing to find the processing order. So this is the sequencing order. Right. Okay. After finding the sequencing order, so here this is B to E, E to D, again D to A and A to C. Now after finding the sequencing order, find out the in and out time for the machine 1 and machine 2. So to calculate in and out time, let us come to this. So write down the number of jobs in this sequencing order, that is BE, BE, then DAC. DAC. This is the sequencing order. So we have to arrange the jobs in sequencing order, just that we have obtained from this. Then write down the in and out time for the machine 1 and machine 2. Now let us come to this. Here for machine 1 corresponding to B, what is the minimum value in machine 1? So in machine 1, the minimum value corresponding to E is, it is 3. So therefore the beginning value, the in time is 0 and the out time is 0 to 3. Okay, again for E, it is for E in the machine 1, the time is 8. So in time is 8. So therefore the in time is 3 and the out time is 3 plus, just add 3 plus 8, that's equal to 11. Okay, the initial time, see here, the initial time for the machine B is 0 and the out time is 3. So initially it is 0, then the total time taken is 3 hours. After that it will goes to machine E. For the machine, for the job E in machine M1, the first in time is 3, then what is the out time? So we have to add 8 from this. So 3 plus 8 is equal to 11. Again for the machine M1, for the job D, the first in time is 11 hours and out times corresponding to D, find out the value. What is the value corresponding to D in M1? We have 7 hours. So plus 7, that's equal to 18. So the out time is equal to 18. Now this out time will becomes the in time for the machine M1 in A, and the out time, just find out the value of A. What is A? A value is equal to 4 hours. Just add 4, this becomes 22. The out time will be the 22. Again for the machine M1 for job C, the in time will be 22. And what is the out time corresponding to C? Corresponding to C, it is 5. Therefore you can add 5 for this. This is equal to 27. So the out time is equal to 27. So this is in and out time for the machine M1. Similarly, find out the in and out time for the machine 2. Initially, for the machine 2, we have to consider this. So here the in time will be 3. So the in time will be 3. And what is the out time? Out time corresponding to B in M2. M2 in M2 corresponding to B, what is the time? We have 9 hours. So let us add 3 plus 9, that's equal to 12. This is 12, 3 to 12. Now see next. So see here, now come to the machine 2. In machine 2, the in time will be the last time of this machine 1, that is 3 hours is the in time, and the out time will be corresponding to this. We have 9 hours, add 9, so 3 plus 9 is equal to 12. Again for the job E, the in time for the machine will be 12 hours, and corresponding to E, find out the value. What is the value corresponding to? We have 5 hours, just add 5 here, this is equal to 17. The out time will be 17. So corresponding to E, here the in time is 12, the out time corresponding to E, it is 12 plus 5. 12 plus 5 is equal to 17 hours we will get. Now check this, the out time must be greater than this time. So here it is 18 and 17. Here the machine has to wait for 1 hour. So here this machine has to run for 1 hour. So this time becomes 18 hours. 18 hours. The ideal time for this machine will be 1 hour here. Okay. Then now see here, I'll explain once again. Here this 18 is greater than 17. 18 is greater than 17. We have to wait for 1 hour. So therefore the ideal time of this mission M2 for D is 1 hour. So 18, and corresponding to this 18, what is the value of D we have? 3. So 18 plus 3. So what is this? 18 plus 3 is equal to 21. So the out time will be 21. Again, for this, again observe this. This 22 is greater than 21. Again 22 is greater than 21. Again this mission has to wait for 1 more hour. Therefore the ideal time is 1 hour here. Then 21 plus 1 is 22. And for this 22 corresponding to A, what is the time? So we have A, for A it is 2 hours. So that is 2 hours. 22 plus 2 is equal to 24. So it is 24 hours. Okay. This is 27. The out time is 27, whereas the in time for this is 20. Since 27 is greater than 24, 27 is greater than 24, this mission has to wait for 3 more hours. 24, 25, 26, 27. So this, the ideal time is 3 hours here. So 27, and corresponding to C, what is the value we have? Corresponding to C, it is 1. 27 plus 1 is 28. Okay. So initially, what is the ideal time? This mission has to wait for 3 hours. So the ideal time for the mission M2 is 3. So if you add, so you see the ideal time for the mission M2 will be 3 plus 1, 4 plus 1, 5. 5 plus 3 is totally 8 hours. So the ideal time for the mission M2 is 8 hours. And now just find out, now in the problem what is given, this is how we are going to arrange. Okay. Now this is how we are going to find out the ideal time and the time, total time lapsed. Okay. Now find out the total run time. So the total run time will be the 28 hours. So therefore, I'll write here, therefore the total run time is equal to 28 hours. This is the total run time. Okay, then ideal time for mission M1 is nothing but the difference between these two, 28 minus 27. Ideal time for mission M1 is equal to 28 minus 27, that is equal to 1 hour. See, initially it has to wait for 1 hour. Next is the ideal time for the mission M2 will be 3 plus 1 plus 1 plus 3. The ideal time for mission 2 M2 will be, that is 3 plus 1 4 plus 1 5 plus 3 is 8 hours. This is how we are going to calculate the total run time and the ideal time for the mission M1 and ideal time for the mission M2 also. So this is how we are going to calculate. Okay. To solve this problem, let us find out the sequencing order. The sequencing order is to be determined. Now let us find out the sequencing order. This is 1, 2, 3, 4 and 5. This is for mission 1 and mission 2. Okay. Now write down this here first. Write down the table here like this. So this is mission 1, M1 and M2. The jobs are like this. Write down J1, J2, J3, J4 and J5. Write down the values for the mission we have. This is 5, 1, 9, 3 and 10. For the mission 2 we have 2, 6, 7, 8 and 4. Now find out the sequencing order now. So to find the sequencing order, as you know, just select the least value, least time. What is the least time we have here? 1 is the least time, that corresponding to J2 job. So therefore this is J2, that is nothing but mission number 2. Now similarly, find out the least value. Again, what is the least time here? It is 2. This is for mission 2, which comes for J1. That is on the right side. So this is for job 1 and for the mission M2, and this is nothing but J1 is nothing but 1 here. Right. Mission 1, mission. Now next least time, yes, this 3. So corresponding to J4. That comes in the left. You can write J4 here. So for the mission, what is the mission here? It is 4, 2, 4. Next least value 4. So strike this. This is for the machine 2, that is nothing but J5. Fifth one. The last least value is 7 corresponding to J3. See, that is nothing but J3 means the third one. See the sequence. First J2, J4, J3, J5, J1. That is second, fourth, third, 5 and 1. This is the sequencing order. So 2, 4, I will write here 2, 4, 3, 5, 1. 3, 5, 1. That is nothing but here it is J2, J4, J3, J5 and J1. This is the sequencing order. The processing order, the sequencing order is this is, that is J2, J4, J3, J5, J1. Now let us find out the total time lapsed and the ideal time and the total run time. Now for this we have to calculate in and out time for the machines. Now okay, let us go to the next table. So here in and out table, the processing order is 2, 4, 2, 4, 3, 5, 1. See, 2, 4, 3, 5, 1. Yes, 2, 4, 3, 5, 1. 2, 4, 3, 5, 1. Right. Now, let us come to the machine 1. So, let us write down the in time. In time it is 0 for 2. In time is 0 for second. The out time is 1. So, it is 0 to 1. Out time is 0 to 1. Then, for the next J4, for fourth machine, J4, the out time will be 3. So, therefore, here the in time is 1. So, 1 plus 3 is equal to 4. It is 4 out time. For the next machine, the in time will be 4. And what is the out time for J3 machine? So, J3 it is, what is the value? That is 9 we have. So, add 9 for this. 9 plus 4 is 13. The out time is 13. Similarly, for next machine, J5. For this, the in time is 13 and corresponding to J5, what is the out time we have? J5 will perform for 10 hours. So, add 10 for this plus 10, this is equal to 23. The out time will be 23. Again, for the machine 1, J1, the in time will be 23 hours and corresponding to this J1, what is the time we have? 5 hours. Add this plus 5, this is equal to 28. So, this is the in and out time for the machine 1, M1. Now, similarly, find out for the machine 2. Now, for the machine 2, the in time will be this 1 hour. Okay. So, 1 hour is the in time. Then here, this machine will be idle for 1 hour because 0 to 1 hour, this will be idle for 1 hour. So, therefore, 1 hour is the in time. And what is the out time? Out time corresponding to 2 in the machine 2. Corresponding to J2. Corresponding to J2, the time is 6. So, you can add 6 here. 1 plus 6, that's equal to 7. The out time is 7 hours. Okay. Next, again, for the machine J4, the in time will be 7 for the machine 2. And corresponding to J4, what is we are going to get? J4, it is 8 hours. So, 8 hours, that is nothing but 8 plus 8. So, this is equal to 15 hours. Out time will be the 15 hours. See. So, again for the machine M2 for corresponding to J3, the in time will be 15 hours. So, this 15 is greater than 30, no problem. So, there is no need to wait. Okay. Then, the out time corresponding to machine J3. J3 will be how much? 7 hours. So, you can add 7 for this. 7 plus 15 is 22. So, the out time will be 22 hours. Again, for the machine, again for 5, see here, 23 is greater than 22. 23 is greater than 22 means the machine 2 has to wait for 1 hour. He has to wait for 1 hour. So, 22 plus 1 is 23. The in time will be 23 and the out time for this corresponding to 5 J5, corresponding to J5 we have 4 hours. Add 4 hours for this 23 plus 4 is 27. So, you will get 27 hours here. Okay. Again, if you compare this 28 and 27, here 28 is greater than 27. That means this machine has to wait for 1 more hour. 1 more hour. So 27 plus 1 is 28. So then corresponding to J1, what is the value we have? We have 2 hours. So add 2 hours for this. 28 plus 2, that's equal to 30. This is the 30. So the total time is 30 here. Okay. Now here the total time lapsed is 30 minutes. The total time lapsed is 30 minutes for the machine 2. Ideal time for the machine M1 is 30 minus 28 is 2. And total time lapsed is 1 plus 1 plus 1, that's equal to 3. That's it. So I will write in the next line. So therefore, the total run time, therefore the total run time is equal to 30 hours. So the total run time is 30 hours. Correct. See here, this is the total run time. Next, ideal time for machine 1. Ideal time, machine M1. Ideal time for machine 1 is 30 minus 28. 30 minus 28 is equal to 2 hours. This is the ideal time for the machine M1. Similarly, ideal time for the machine 2, M2 is equal to, what is the ideal time? 1 plus 1 plus 1. 1 plus 1 plus 1 is equal to 3 hours. This is the ideal time for the machine 2. So therefore, the total run time or elapsed time is equal to 30 hours. Ideal time for machine M1 is 2 hours. Ideal time for the machine M2 will be 3 hours. That's it. Okay. So this is how we are going to solve the problems based on this concept. Now that's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.